Hey guys, Mr. Bowman here. We're trying out the video webcam again. Today's learning objective is in Orange, and we are learning to define and identify prime numbers. So this is something many of us may done before, but let's quickly recap what is a prime number, and we'll go through some examples and an approach as to how to identify when a number is a prime and when is it not a prime. So a prime number, it is a number, and I'm going to write in brackets a whole number because we normally only look at whole numbers or integers, and it's something it can only be divided by the number 1 or itself. So that means if there is a third or a fourth number that can be divided into that number that's not 1 or the same number, then those will not be prime numbers. So I've got 6 examples written down on a refill pad next to me. We're going to go through them all. So the first one I want us to look at is the number 3. We've got to think, is it a prime number? So we've got to think what numbers can be divided. So 3 divided by what numbers will give us whole numbers? So let's have a look. So if we divide that by 3, well, 3 divided by 3 is going to be 1. So that's a good start. If we divide that by 1, that's going to be 3. So again, good start. So currently that's only meeting the numbers. So we're only dividing it by itself, which is a 3 or it's 1. Can you think of any other numbers that can be divided into 3 that gives a whole number? I can't. No. So that means here the only factors are 1 and 3, which means that 1 is a prime number. So I'm going to write prime there. So I'm going to change the pen color. We'll go for orange now. The next one I want us to look at is the number 10. So what numbers can we divide 10 by to get other numbers? So the obvious one, we can always divide it by itself, which will give us 1. And we can always divide it by 1, which will give us 10. So those two are always going to be true. We can always divide by itself, divide by 1. But are there any other numbers? If there are, that makes it not a prime number. And this one here, I can think of a few actually. I think I can divide that by 2 to get 5. And I can divide that by 5 to get 2. So that means we've got actually quite a few factors this time. We've got 1, 2, 5, and 10. So that means there are numbers other than 1 and itself which can be divided by that number, and that makes it a non-prime number. So the presence of that 2 and the 5, that makes it non-prime. Let's find another pen color. We're going for the pink one this time. Now, we're going to look at the number 7 now. Let's have a think. What numbers can we divide that by? We can always divide it by itself. So 7 divided by 7 will get us to 1. And it can always divide it by 1. So 7 divided by 1 is going to get us to 7. Are there any other numbers that you can think of that'll give us a whole number? No, I can't think of any off the top of my head. 2 would be weird. 3, 4, 5. No, all of those would be weird, wouldn't it? 6? No. So no other numbers, I don't think. So that means the only factors of 7 are 1 and 7, and that is 1 in itself, which means, again, we're going to get a prime number there. So let's change pen colors. We're now up to blue. We're looking at 15 now. So let's have a look. What numbers can be divided by 15? So 15 divided by 15 will get us to 1. Divided by 1 will get us to 15. So there are the standard ones that are always going to be the case. Can you think of any other ones that will be divided by 15 to get us a whole number? I can think of a few more, just like 10. I can think if I divide that by 3, I'm going to get 5. And if I divide that by 5, I'm going to get 3. Are there any others? Can't think of any others this time around. So that means we're going to list our factors. So we can have 1, 3, 5, and 15. So the key thing is to note I've listed these, and I've listed them in order as well. And because there are other numbers, we've got the 3 and the 5 there, that is going to make it a non-prime number. And we'll quickly go through our last 2 examples. We'll switch to the green pen. The next one I wanted to look at was 33. So 33 divided by 33, well, that'll get us to 1. 33 divided by 1, that's going to get us to 33. We've now got to think, are there any other numbers apart from 1 and 33 that can be divided into that number? So you may need to play around with your calculator to get some of these, but just from experience, I know if I divide that by 3, I'm going to get 11. And if I know that, I can divide it by 11 to get 3. I can't think of any other factors or any other numbers that can be divided. So that means my factors are 1, 3, 11, and 33. And the fact that 11 and 3 are also factors, that is going to make that a non-prime number. Non-prime. And finally, the last one I want us to look at is 17. Lucky 17, some say. We're going to go, again, divide by 17. That'll get us to 1. Divide by 1. That'll get us to 17. Can you think of any other numbers relating to 17 that'll give us a whole number through division? No, I don't think I can. So that means those are my only 2 factors. So you may want to mess around with a calculator to see if there are any other numbers. So try the common numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we can't in this time. Okay, so let's have a look. So our only factors are 1 and 17, and that makes it a prime number. So hopefully you found this video useful. This is also going to be helpful for when we look into factor trees and developing prime factors.